Balancing ionic equations. When ionic compounds dissolve in water, they separate into ions. Not all ions take part in the reaction. The ions that don't participate in the chemical reaction are called spectator ions. The ionic equation is a simpler form of chemical equation where all spectator ions are omitted and only ions playing a role in the reaction are presented. To understand better, let's apply on this example the reaction of zinc metal with copper sulfate to give zinc sulfate and copper metal. To be able to identify the spectator ions, we need to write the charge on all ions. Remember, only ions. We write positive 2 on the copper ion, negative 2 on the sulfate ion, positive 2 on the zinc ion, and negative 2 on the sulfate ion. Notice, sulfate ion didn't change throughout the reaction. It appeared on both sides and didn't change, where zinc metal lost 2 electrons and formed zinc ion, where copper ion gained 2 electrons and formed copper metal. Let's solve this exercise. Write the ionic equation for the full balanced equation magnesium reaction with hydrochloric acid to give magnesium chloride and hydrogen gas. The first step, we write the charges on all ions. It is better to separate all ions to keep the balanced equation. We write magnesium solid plus 2 hydrogen ions plus 2 chloride ions to give 1 magnesium ion, 2 chloride ions, and water molecule. You can see the 2 chloride ions appeared on both sides and didn't change. So we cancel chloride ions from both sides. Finally, we write the ionic equation. Magnesium solid plus hydrogen ions to give magnesium ion plus hydrogen gas. Let's solve another exercise. Write an ionic equation for the full balanced equation, the reaction of bromine solution with potassium iodide to give potassium bromide and iodine solution. First, we separate the ions. Bromine solution plus 2 potassium ions and 2 iodide ions to give 2 potassium ions and 2 bromide ions and iodine solution. Second, we cancel the spectator ions. You can see the potassium didn't change throughout the reaction, so we cancel the potassium. Finally, we write the ionic equation. Bromine solution plus 2 iodide ions to give 2 bromine ions and iodine solution.